I'm going to demonstrate how to use Microsoft Excel to build a calculator for adding vectors. Shown here are vectors A, B, and C along with all three vectors connected head to tail to graphically create a resultant vector. The table below shows the calculations for the horizontal and vertical components of each vector that are summed here to find the components of the resultant vector. Our spreadsheet calculator will utilize the horizontal and vertical component method to calculate the magnitude and the direction of the resultant vector. I've already set up my table with my vector names in the first column, my input columns for magnitude and direction, which I'm calling reference angle for each vector, a column to display my radian conversion, and the calculated horizontal and vertical components, which I've designated as X and Y respectively. From there, I can program trigonometric calculations to find the magnitude and direction of my resultant here. So let's begin by keying in our magnitude and direction for each vector shown on the right. So for A, I have a magnitude of 30 and a direction of 0 degrees. For vector B, a magnitude of 20 and a direction of 45 degrees. And finally, C is 50 pounds, and my direction is 120 because it's from standard position or 0. I now want to program my X and Y columns to calculate horizontal and vertical components, but I must first convert my degree input into radians. Excel natively recognizes angular values as radians for trig functions. So for those of you who are familiar with converting radians to degrees, you know that we can multiply the degree value by pi over 180. A simpler approach in Excel is to simply key in radians followed by the calculation or the cell reference. So for D2, I'm going to program this as equals radians, and my cell reference is C2. Okay, and I will copy that down. So as you can see, my reference angles in column C have now been converted to radians in column D. For our X component here, we will use the cosine function. So this will be equals B2, which is my magnitude, and I will multiply that by the cosine of my angle in radians, and I will copy that down. Okay, now for my Y component, I will need to use the sine function. Equals my magnitude multiplied by the sine of my radian angle, and I will copy this down as well. Okay, so now that I've done that, I can now auto sum the columns for X and Y. And I will copy this over. All right, so this is the X component for my resultant vector, and here's the Y component for my resultant vector. And using these values, I can calculate magnitude using Pythagorean theorem. So I'll program this cell as equals SQRT being square root of my X value, and I will need to square that. So that's shift 6 for my caret 2 for an exponent of 2 added to F9, which is my Y value, squared also. That will give me my magnitude of the resultant, and then I can also use these values to determine my direction. So I'll program the cell as equals, and I'll need to convert back to degrees. So remember, I'm working in radians. So in order to convert to degrees, I will need to simply key in degrees, and then my calculation, which will be inverse tangent, or as Excel knows it as arctangent, atan, of my y component over my x component. Oops, typo. Will I accept the correction? Absolutely. I forgot a parentheses there. Okay, great. So my direction in degrees is 71.6. So I've now fully defined my vector. So I now have a fully functioning calculator. So I'm going to leave all my cells programmed, and I can come into my B and C column. I can right click after selecting my cells. I can clear contents, and now it's ready to input another set of vectors.